Now we will see rectangular coordinate system. This is a rectangular coordinates, x and y axis are there. X comma y is an ordered pair representing the point on the xy plane. 2 comma 3 represent x coordinate is 2 and y coordinate is 3. So x is equal to 2 here, y is equal to 3 here. This is the point. Abscissa is called x, ordinate is called y. 2 comma 3 is not equal to 3 comma 2. Please, a comma b is not equal to b comma a. X comma y is not equal to y comma x. They are different locations. 3 comma 2 means you take 3 along the x-axis, 2 along the y-axis. So somewhere here it will be there, not closer to the y-axis. And we will see the distance formula. There are 2 points here, a and b. A is x1 comma y1, b is x2 comma y2. We want to find out the distance ab. Distance ab is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Suppose it is a 3-dimensional point. A is x1 y1 z1, b is x2 y2 z2. Then distance AB is root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Now we will see section formula. There are 2 points A and B, and A is x1 comma y1, B is x2 comma y2, C is in between, and C x comma y is equal to m times x2 plus n times x1 by m plus n. Please note, I have taken n for a coordinate for m opposite side point x2 comma y2. And if the point is beyond, so AB is here, C is somewhere here, then what we do is, D is the point, we want to find out the ratio of m is to n, then d of x comma y is equal to m times x2, please note this point, and then n times x1 minus divided by m minus n. Please know m is a greater value than n. Similarly, y coordinate is m by 2 minus n y1 divided by m minus n. This is how you find out. Now we will see area of the triangle. A, B, C are the vertices. The area is given by 1 by 2 times. You take all the x values in the first column, y values in the second column, 1, 1, 1 in the third column. So you can find out the area like this. Right? You can also find out by transposing this. See, 1, 1, 1 in the first row, 1, 3, 5 x coordinate in the second row, y coordinates in the third row, and you will get the same result. We will do an example. See, A is 1, 2, B is 0, 1, C is 2, 1 are the vertices of a triangle. We will find out the area of this triangle, and this is one way. We will get the answer as 1 square unit. This is another way. 1, 1, 1, 0, 2 and 1 x coordinates, 1, 1, 2 is the y coordinates. Substitute, you can use this relation, 1 into 2 into 2, 4 minus 1 into 1, likewise. I have given the answers here, and A1 B3, right, A1 into B3 is this 0 into 2 minus 1 into 1, 0 minus 1. Similarly here A1 B2, A2 B1, right, A1 B2 minus A2 B1, 2 minus 0, right, okay, plus 1 into A2 into B, A1 into B2, A1 into B2 is 0, 1, A1 into B2 is 0, 1, minus 1 into 2 is minus 2, okay. So A1 B2 minus A2 B1 is 0 minus 2. So add, you will get the same 1 square unit, okay. Now you will see slope of a line. Y is equal to mx plus c is the equation of the line, where m is the slope and c is the intercept, y-intercept. X-intercept is minus c by m. We will not bother about. Here c is the y-intercept, we should know. Because when x is equal to 0, y is equal to c. If slope of line L1 is m1 and slope of line L2 is m2, then for line L1 to be parallel to L2, m1 should be equal to m2. Line L1 is perpendicular to L2 if m1, m2 is, the product of the slope is minus 1. Very important. Then you will get to parallel and perpendicular lines here. You have already seen it, we will see once more. Line L1 is parallel to L2 if m1 is equal to m2. What is m1 and m2? Slopes. Line L1 is perpendicular to L2 if m1, m2 is equal to minus 1. Y is equal to 2x plus 3 and y is equal to 2x plus y are parallel lines. Please note, C1 is not equal to C2, 3 is not equal to 5. y is equal to 3 minus 2x and y is equal to 1 by 2x plus 5 are perpendicular lines because minus 2 into plus 1 by 2 is minus 1. Then we will see this representation of a line. Y is equal to mx plus c is the equation of the line in slope form. Y minus y1 is equal to m into x minus x1. So we can use this formula. And then representation line 2, another method is using direction. Y minus y1 by y1 minus y2, x minus equal to x minus x1 by x1 minus x2 is equal to z minus z1 by z1 minus z2 is equal to lambda. This y1 minus y2, x1 minus x2 and z1 minus z2 are all named here. Here x minus x1 by x2 minus x1 minus x2 is L here. Here it is M. It is for Z. It is denominator is N. L, M, N are called direction cosines. The square of L and square of M and square of N, if you add it, you will get 1. Right? Because that is why it gives direction cosines. This is nothing but cos theta x, cos theta y, cos theta z. With respect to x-axis angle, with respect to y-axis angle, with respect to z-axis angle. And proportionate to these direction cosines, we got direction ratios ABC. And this ABC in terms of known points, we are giving it as x1 minus x2, y1 minus y2 and z1 minus z2. We will see general equation of a line. Standard form is ax plus by is equal to c. General form is ax plus by plus c is equal to 0. I will use small letters also. Ax plus by plus c is equal to 0. Here x intercept is given by minus c by a, y intercept is given by minus c by b, and slope is given by minus a by b. Please remember this formula so that you can get the general form equation given the intercepts and slope. Intercept form x by a plus y by b is equal to 1. X intercept is a, y intercept is b. This is another way of writing the equation. Point slope form is y minus y1 is equal to m into x minus x1. One point is given, slope is given. So point and slope are given, you can get this equation. 2-point form, only 2 points are given, x1, y1 and x2, y2. You can find out the equation is y minus y1 by y2 minus y1 is equal to x minus x1 by x2 minus x1. We'll get a standard form using a point on a line. See, this is a line, this is a point, and the direction is given by ai plus bj plus ck. This is called the direction ratios. And the point is x1, y1, z1. We want to find out the locus of all the points on the line, that is x, y, z. We will get x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda, a constant. For varying constant values, we will get varying points on the line. A general point on the line is assumed as r x1 plus a lambda, y1 plus b lambda plus z1 plus c lambda. How far is it from x1, y1, z1 along the x-axis, y-axis and z-axis? That gives the location r of x, y, z. Then we will see equation of a parallel and perpendicular lines in general form. F of x is equal to m1x plus c1, g of x is equal to m2x plus c2. Then lines fx and gx are parallel if m1 is equal to m2. Lines fx and gx are coinciding if m1 is equal to m2 and c1 is equal to c2. Lines fx and gx are perpendicular if m1 into m2 is equal to minus 1. Slope m1 is equal to 0 for a horizontal line. Y is equal to c1 is a horizontal line parallel to x-axis. Slope m2 is equal to undefined for a vertical line because there is no coefficient for y, so undefined. These two lines are perpendicular. X-axis and y-axis are perpendicular, we know. A line parallel to x-axis and a line parallel to y-axis will also be perpendicular. But m1 is not equal to minus 1. Right? These two lines are perpendicular, but product of the slope is not minus 1 because one is undefined. Does this contradict the definition of perpendicular lines? No, because vertical line is not a function. Because for one input, outputs are many. So hence the definition. Now we will find the equation of a perpendicular line passing through a point. A line L1 passes through the points 1, 4 and 5, 2. If the line L2 is perpendicular to L1, then which of the following represents perpendicular line L2? Options are given here. We have to find out the equation of the line L2. Line L1 is equal to y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. Substituting the points x1, y1, x2, y2, we get y minus 4 by 2 minus 4 is equal to x minus 1 by 5 minus 1. Now we can substitute, reorder, and you will get y is equal to minus 1 by 2x plus 18 by 4. Simplifying 18 by 4, we get L1 equation is y is equal to minus 1 by 2x plus 9 by 2. Therefore, slope is minus 1 by 2. M1, M2 is minus 1. Substituting, we will get slope of M2 is minus 1 by M1, that is minus 1 by minus 1 by 2, which is 2. And the equation should be y is equal to 2x plus 3 or 2x minus 3. But 3, 3 is a common point because 3, 3 is a midpoint of this line and it passes through the perpendicular also. Therefore, substituting 3, 3, you get y is equal to 2x minus 3. So this is the correct equation. Equation of a perpendicular line passing through a point will continue. Here the same problem, line L2 is perpendicular bisector of L1. Then which of the following represent perpendicular line L2? Same thing, we are using the equation using the coordinates x1, y1, x2, y2, simplifying it. Slope is m1 is equal to minus 1 by 2, slope is m2 is equal to 2 plus 2. Y is equal to 2x plus c is the equation. We have to find out the constant by substituting the bisector point on the line L1, which is 3, 3, which is the point on the line. So substituting, we will get c is equal to minus 3. Therefore, y is equal to 2x minus 3. Rearranging, 2x minus y is equal to 3 is the equation. Option 2 is the correct answer. Then we will see distance of a line from a given point. The line is given by ax plus by plus c is equal to 0. Point is given by x1, y1. Distance d is equal to modulus of ax1 plus by1 plus c. That is, you substitute absolute value, in fact, divided by root of a squared plus b squared. Distance has no signature. Therefore, you get absolute value of this ax1 plus by1 plus c. A, b, c are obtained from the equation of the line. X1, y1 are obtained from the point given. And substitute, you get the answer. On straight line fit, I will show you the equations. So you can, this is an equation. Given the 2 points, you can find out. Straight line y is equal to x plus b. Parabola y is equal to x square plus bx plus c. Cubic y is equal to x cube plus bx square plus cx plus d. All are using lines only, curved lines. Exponential y is equal to a into e power bx. Exponential y is equal to a b power x. Exponential y is equal to a into x power b. These are all the equations given here. Standard form, general form, x-intercept, y-intercept is given and slope is given. X-intercept is minus c by a, y-intercept is minus c by b, slope is equal to minus a by b. For all the coefficients, for all the intercepts and slopes, negative sign is used. C is used for both intercepts and a and b are used in the same order, a by b. And x is obtained using a and y is obtained using b. Y-intercept is obtained using minus c by b. X-intercept is obtained using minus c by a. Intercept form x by a plus y by b. If intercepts are given, you can straight away use this. Point slope form, y minus y1 is equal to m into x minus x1. 1 point and slope is given. 2 point form, 2 points are given. Then you get this equation. This is 2 endpoints of a line AB are A vector and B vector. The point also can be represented in vector form. The A is given with the form. I will give you. Find the vector A in Cartesian vector form. Find the vector B in Cartesian vector form. Find the vector AB in Cartesian vector form. This is a questions. I will give you the answer. Please see here. A is given here. The y coordinate is 2. X coordinate is 3. And z coordinate I will say 0, right? So 3 to 0 is the A point. We'll see here. So 3 to 0 minus 2 because it is below x axis, and B is minus 3i plus 4j plus 3k. See here, B is here, right? And you can see here 4j upside and minus 3i towards negative, this 3, and z also is towards positive here, right? This is positive, this is negative. And AB is given by b vector minus a vector. Simply, the calculations are very simple in this case. And modulus of AB is root of x squared plus y squared plus z squared, you can get. And direction cosines you can obtain for this line, because which direction it says, unit vector in this direction AB is minus 6 by the square root of this modulus of AB, minus 6 by 9 and plus 6 by 9 and plus 3 by 9. And simplify, you get minus 2 by 3, 2 by 3 and 1 by 3. This is called direction cosines. Right. The equation of a straight line can be written as x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Here ABC is replaced by LMN. Any proportional values you can do. Because 3 is a common factor, take it out, it becomes minus 2, 2 and 1. So minus 2, 2 and 1 are called direction cosines. Right. And the angles are given like this here. Alpha is equal to cos inverse of minus 2 by 3 and beta is cos inverse of 2 by 3 plus 2 by 3 and gamma is cos inverse of 1 by 3. That completes the session. Thank you very much.